Hello, and welcome to the Hard Tech Podcast. I'm your host, Daniel Apo. I'm a mechanical engineer and founder of multiple hardware tech companies. Today, my guest is Alex Villanueva, the founder and CEO of Eclo, an AI research company dedicated to sustainability in the apparel industry. Alex has 15 years of experience as a mechanical engineer working on diverse projects ranging from biomimetic jellyfish robots to unmanned aerial vehicles at NASA. Alex is also a dear friend of mine. I've known him for many years since first meeting in graduate school. Please join us as we further delve into his journey. Let's talk about Eclo. What is Eclo and what problem are you solving?
Eclo is a virtual fitting company. Basically, we help online shoppers figure out what shoe size they need. So when you shop online, it's hard to know what size you need, for clothes or for shoes. And this is actually a pretty big problem that leads to a lot of returns, a lot of money lost for retailers, and ultimately also leads to a lot of pollution. From the carbon footprint associated with these returns, but also a lot of things that are ordered actually end up in the landfill, right? Or end up being wasted one way or another. So Eclo is set to solve all of these things. It's beneficial to the retailers, to the shoppers, and also to the environment.
So let's get into telling the audience or informing the audience about how big this problem is. Just ballpark values here. What percentage of returns for apparel products would you say is due to size fit issues? If you have to break it down by category, shoes, clothing, and all that stuff.
So let me say this: 45% of all online returns, like electronics, whatever. 45% of all online returns is clothes and footwear.
Wow. Okay.
Yeah. About 30% of clothes and footwear are returned. So for any article, any 100 article ordered online, about 30 of them are returned. So that's, billions of pounds. If you look at the worldwide numbers, it's billions of pounds of CO2.
Yeah.
That's billions of pounds of clothing ends up in the landfill. So yeah, it's pretty big numbers.
Yeah. I mean, if you buy a shoe from Nike, for example, and you try it on and then it looks used and then you return it, Nike can't sell that. You don't go on Nike and buy used shoes, do you?
Right.
So that means you're going to have to throw it away or something.
Right.
Or maybe try to discard it in some other way through liquidations, but that's a lot of waste.
It's a lot of waste.
30% of all shoes sold or all clothing sold is returned. And most of them can't be resold.
Yeah, that's right. Every company has different strategies for how they handle their returns. Some of them have, like secondary channels that they'll be able to sell used clothing or whatever. But yeah, some of them, thinking mostly of like the super high-end, super high-end brands like Gucci or something, right? They just throw it away.
Yeah.
Right. So yeah, it varies between that, right? And I think some of them we just don't really know what they do. So yeah, ideally there would be no returns, right? Ideally you would order something and it fits you.
Yeah.
And then none of that has to happen.
Okay. So let's get into the inspiration for Eclo. So what inspired you to create Eclo? Would you say you're a shoe collector or just an environmentalist? What is it?
Probably more the second, for sure. Definitely not a shoe collector.
You're not a sneakerhead, no?
Not at all. Though I have realized over the years that I did have a lot of different types of shoes because I do a lot of different sports. So I remember at one point I counted I had like 10 different types of shoes, like snowboard boots, ice hockey skates, rock climbing shoes, like things like that. So in that sense, I do have a lot of shoes and I am very like particular about fit for like performance, but definitely not a sneakerhead or something like that. I think the environmental aspect is probably more important for me. And as far as like your first part of the question, the inspiration, it actually came to me when I was at Virginia Tech in grad school. And as you remember, we're really busy, constantly trying to meet deadlines, trying to publish a paper, turn in a homework. It's kind of like nonstop, right? And the slightest thing that would prevent us from just working was a distraction, and we just always kind of try to like remove those, right? So I remember one time it was in the middle of winter, and my boots like were coming apart. Literally, like the sole was coming off from the upper. So I had this like talking boot, and so I needed new shoes, and I went online. And I was trying to figure out like, okay, what do I need? What size should I use? Should I order? And I was just thinking to myself, like, there's got to be a better way to do this. I don't want to have to go to the post office, because I don't know if you remember, but Blacksburg post office was always a huge line. We didn't want to go there, stand in line and, deal with returns. So it was like, if I'm going to have to do that, then I might as well just go to a store or something, right? So so that was part of it. The other part of it was I ordered a pair of glasses not too long before then from Warby Parker. And at that time, Warby Parker was just kind of taken off. Now they're a billion-dollar company and super successful. But back then it was, pretty small still. And one of the cool things they had was this virtual try-on, where you could put in glasses on your face and see how they fit virtually, right? So you would take a couple of pictures, then they would superimpose the glasses on the pictures. Okay. And I thought that was the coolest thing ever, right?
How long ago was this?
This was...
No, I mean, the reason I asked this question is nowadays, you have this on a lot of e-commerce websites, but it seems like Warby Parker was doing this before anyone else would.
I think so. It's the first one that I saw.
Yeah.
And that was about 15 years ago. That was 12 to 15 years ago.
Yeah.
Yeah. So when I saw that, I was like, whoa, this is cool. Like, why can't I try on my boots like that, right?
Yeah.
So yeah, exactly. I thought it was pretty revolutionary at that point. And so yeah, I ordered glasses from them after trying them on virtually. They sent me like 5 different styles, and I tried those on, and I thought the system was cool, and I kind of saw a glimpse of how e-commerce was going to become, So when I came time to order my boots, I was thinking to myself, why can't it just be like Warby Parker, right? Why can't it, and then take it to the next level and tell me what size I need? So yeah, that was kind of just an idea that came to me like that. I had a bunch of other ideas, but that was one of them. And the other thing that I think was important for me to figure out back then was, am I the only one with that problem of, not knowing my size, right?
Yeah.
I thought to myself, like, that's got to be very specific to people who are not close to stores, like, or big cities, because Blacksburg was, kind of far away from everything.
Yeah.
I was thinking to myself, like, people in DC, they probably don't have that problem because they can just go to the mall or the other mall, a lot of options. But no, it was, the more I talked to people, the more I realized this was a pretty common problem. Regardless of where you live, people like to order online because it's easier, it's more convenient. There's more options. Sometimes there's better deals. So, not knowing your size was something that was pretty universal as far as I could tell.
Yeah. Yeah. It's a very, very good background story for the creation of something like this. Okay. Let's talk about what Eclo could do or is doing to revolutionize the way we shop for shoes. On your website, it says 30% of shoes, you already said this, 30% of shoes bought online are returned. So can you definitively say what Eclo would do to that number?
Eclo will at least reduce that by half. Okay, that's what we know. How much more than that? That's tough for now for us to say. Until we have more data, I don't really know how much more. But I think it could be that 30% could be down to like maybe 5%, right? I think it could be a very small number. There's always going to be, some like cases where, it's just too hard for us to know the fit, or, of course, there's going to be other reasons that people return things. But the more we learn about fitting and what people prefer, the better we get, and I think the more successful, the more I see like, okay, yeah, this is definitely going to be something in the future that works really well.
But a 50% reduction in the return rate, to make it simple, reducing the return rate overall to 15% is huge. That's a lot of savings in terms of for brands and for retailers, and for even for in terms of the convenience to the customer also.
Definitely.
That's, even what's 15? Even 5% is huge.
I have a little story about that. When I was just starting out, I somehow managed to get a meeting with the CTO of Zappos.
Okay.
And that was a huge deal, right? Zappos was like the company where we're basically developing this technology for. Back then. And I was sitting with him, and first of all, he came down. He was like really not in a good mood, I guess. And he eventually told me look, I came down here to tear you guys a new one because I've seen this before and it's not gonna work. And but you guys are nice guys, and I want to help you out. So he said, at some point, he said, if this works and you reduce returns by even 1%, you're a $1 billion company. Right?
Whoa.
So he was just skeptical that it would ever work. Right? So he said, just show me an A/B test with like 5,000 people on A and 5,000 people on B, and then show me that your system improves performance, right? Long story short, that's essentially what I've been trying to do ever since he told me that, right? And it's been really hard to do that, but I forget why I was saying
you were saying that 1%, even a 1% reduction is impressive. I said 5 was impressive.
Yeah, exactly. So to your point, even 1% would be a big deal.
It's the biggest pain point for brands and retailers is returns. No one wants to deal with that stuff. So that's why even a 1% reduction is 1% reduction in stress is it's huge, because then you have 1% less staff, 1% in the returns department or whatever you have. It's also 1% more satisfied customers who don't have to worry about returning stuff. It's huge. So it's a good point.
There's one more thing that I actually realized in the recent years. I didn't realize this in the beginning of the project, but there's probably something that's even more important to retailers than less returns, and that's higher conversions. So I realized that when I was crunching numbers for the business model, and I was calculating how much money they're saving if we reduce returns by say 50%, right?
Yeah.
And then I was also crunching numbers for conversions. And I quickly realized that if we reduce returns by 50%, it equals some amount. But if we increase conversions by 5%, it's even bigger.
Yeah. Yeah.
So then I started understanding why companies were much more excited about small bumps in conversions versus us saying hey, we're going to eliminate your returns.
Yeah.
So that was a pretty big kind of turning point in a way.
It's a really good point. It's a lesson I've had to learn myself too recently. Well, not recently, but over the past few years too. It's easier to sell businesses on making money versus saving money. Whatever you do, if you can phrase it or actually offer a service or product that helps them make money, you are more likely to convert, get a lot more customers than if you try to sell them on saving money.
Yeah.
Or saving time or things like that. So it's something that you learn along the way, right?
Yeah, exactly.
You learn from experience, Okay. So let's explore the technology at Eclo a little bit. How does Eclo as an AI company, and I know you described it as an AI research company designed to promote waste reduction and environmental sustainability by ensuring the correct online shoe purchase. So how does AI determine the perfect shoe fit?
Okay, so first of all, fit. What is a good fit? Right, that's a tough question, and that's a hard question that we thought people knew. We thought the industry knew the answer to that question when we first started. Turns out they don't. In not a lot of words, like they really didn't have good answers for us. Like we were basically thinking like, hey, we'll just approach companies and as tech guys, and then we'll tell them like, hey, tell us what a good fit is, and then we'll just automate it, right? We'll just digitize the whole thing. But we never got a good answer to that. Even to this day, it's been 10 years, and I still, am just getting little pieces of what they think is a good fit. So figuring out what a good fit is has been very challenging, and essentially what we've been working on, right? So that's a big part of it. The AI ultimately takes all the different parameters contributing to what a good fit is, and then figures out, what's the best fit for someone. But getting those parameters is also very challenging. So we have the body is important in this equation of what a good fit is, right? The clothing is important. But then you also have things like personal preferences. Maybe I like to wear my shirts a little looser than you, or maybe I like to have my shoes really snug when I play tennis or something, right? So those are really important. The application is really important. What are you going to wear it for, right?
Yeah.
So all of these little things kind of add up to what a good fit is. And if the second you don't include one of those, your accuracy in terms of size prediction goes way down, right?
Yeah.
And that's what we've seen. A lot of people have tried doing this. That's a common mistake that they've made, I believe, is just not including enough parameters in their predictions. So if you're just taking a survey online, trying to figure out hey, what size I am, and you just click 3 or 4 things, it's probably not going to be very accurate, right?
Yeah.
So yeah, being able to capture the right parameters is one thing, and then knowing what to do with those is kind of the other big part. So yeah, I guess coming back to the parameters, we had to develop a foot scanner that was easily accessible to people, right? So immediately we were smartphones. We got to use smartphones to let people capture their foot information, their body information. So that was a lot of work on its own. That was actually, for a while, that's the main thing we were working on, because there's 2 parts to that problem. The first part is given the right data, can we reconstruct the body? Can we create a 3D model of the foot, or can we get dimensions or whatever, right? So that's one engineering challenge. But then the other challenge, which might be even bigger, is how do we get people to capture that data in the first place, right? And that's a whole other challenge, right? That's a whole other field from what I was used to in my engineering background, because that's a lot of UI, that's a lot of user interaction, user experience, getting it to a point where anybody can actually use your system is really tough. So yeah, foot scanner was a big challenge, getting that right.
So you think the AI integration will help solve these issues, you think? Or does it make it easier? If it was easy to just enter a prompt I know this is not how your AI works, but let's just throw out a hypothetical, right? If it was as easy as just typing in a prompt and say, I need a blue shoe that would fit me snugly and blah, 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 as you're scanning, I mean, just to make it easier, like, for lack of a better word, dummy proof, right? You think that would make it better? Like a lot easier to adopt?
Yeah, for sure. I mean, like I think what you're describing here is kind of merging a couple steps together, right? It's like this the sizing part mixed with the styling part. Right?
Yeah.
Like if you can figure just both of those out at the same time, great. Yeah, that's even better.
Yeah.
So anything that simplifies the journey for the user I think is going to be helpful.
Yeah, it seems like a perfect use case for AI. This is probably what AI was developed for, and not for what it's being used for nowadays in some cases, because one of the biggest reasons people return apparel and shoes or anything that goes on your body period is personal preferences. You can design the best shoe ever, but it just doesn't feel right. It doesn't feel right. It doesn't, and people are going to still return it regardless. So you might be solving more than fit. You might be solving other issues related to returns, or you might actually, let's phrase it in a way that actually works. You might actually be making more money for retailers or brands because now they can say, oh, you know what, Nike, I want a shoe that is this color, fits this way, and does this way, and I'm going to use Eclo's scanner app, and then that just spits out something, and then that just points to something on the Nike website, and that just makes Nike money. It makes, it makes more money for them than they would have if somebody was just, because you go through some websites, right, and you're trying to shop for something, and you go through and like, I can't really find something that works here. And then you lose that customer. Now that's a customer gained because they've gone through and selected their product in a dummy-proof way that is all because of AI. That's what I'm trying to point at.
One of my advisors is this industry veteran in the footwear, and he always says that the main reason people buy a certain shoe is because of fit.
Yeah.
Right? Like my intuition would have said, it's because it looks good, right? I like it the way it looks on me or whatever, right? But from his experience, from selling shoes, putting shoes on the people and selling them to, being the CEO and board director and all that, he says that the main reason is fit is the main reason that people end up picking a shoe and coming back to it, coming back to a certain model year after year. Is because it fits well, right? And it kind of makes sense, right? Because if a shoe doesn't fit well, like you just said, you're probably not going to buy it, even though it looks cool, right? You probably find something that is a compromise or whatever. But yeah.
Okay. Is there a big difference between something fitting you and something being your size?
Yes.
Okay. Let's separate those two real quick.
Yeah, that's a good question. So you might. Your size might be the best fit for a certain shoe style, right? So the shoes you're wearing on right now, that size is probably the best size for you, right? But it doesn't mean those shoes fit you well.
That's true.
So yeah, you could have different shoes fit you differently, and them being your size, all of them being your size.
Yeah. So then the goal will be to find something that's hopefully within your size that actually fits you well.
Yes.
Yeah. And then if you find that and you're always just so comfortable in that shoe, then you're always coming back to it. Or a t-shirt or a shirt that just fits you nice every time from that brand. You're like, okay, I bought the same medium-sized t-shirt from this other brand, but it doesn't just fit me well,
Yeah.
Yeah, I see. I can understand that now. Yeah. Okay. Before we go on into, before we talk more about the app, I know there's a hardware component to what you're doing. Can you briefly talk about that?
Absolutely. So the third part of the technology that we've developed is the shoe scanner. And the shoe scanner is essentially a robot that goes inside of a shoe and creates a 3D map of the shoe, right? Or a 3D model of the shoe. And the reason we built that is because not every company has access to a digital version of their shoes. If that makes sense. So with the robot, we can get a digital model of the shoe that we can use to match or compare to your feet, right? And so the 3D model of the shoe, 3D model of the foot that you've taken with the foot scanner are essentially compared, and from there, a size recommendation is made. It's compared with that and the other parameters that we collected.
Okay.
So the shoe models are either taken with the shoe scanner or they can be obtained directly from the manufacturers, right? Because the manufacturers have what is called a digital last, and the actual last is what the shoe is made with. It's this big plastic piece that kind of looks like the shape of a shoe, and then they build the shoe on top of it. So they have digital version of that.
So like a mold?
Like a mold, exactly.
Okay.
And so we can use the digital version of that mold to get a physical idea of what the shoe is, and then use that to compare to feet.
I see.
So if those are available, great. That's easier. But the actual shoe scans that we take with the robot can also be used. And it can be used in addition, because the shoe scans are the most accurate version of what the shoes end up looking like after they're built, right?
Yeah.
The digital shoe last is more of like the idealized version of what that shoe should be.
I have a deeper question here.
Okay.
You know how there's some shoes that you have to, a lot of shoes you have to break them in, right? So it starts to fit differently, a few weeks or a few days after you start wearing it, right? I think that regardless of the mold or digital model that you get from the manufacturer, the hardware component is still useful for how the shoe fits eventually. Don't you think? Or it doesn't matter? That extra millimeter here, extra millimeter there that just got shifted within the shoe.
Yeah. Okay. So the hardware is very important in making the shoe, of course. If you have any kind of inaccuracies when you're making the shoes, you're going to have some error in your sizing, right? Maybe let's say an example, like you wear a size 11 and you order a size 11, but there was some miscalibration in the manufacturing line, the day your shoes were made. So you're really getting an 11.25, you know what I mean? So your shoes are a little bit bigger than they should be. So, the hardware has a big impact as to how the shoes are going to fit.
So of course, I think the point I'm trying to make here overall is that it might be a situation in which the robot that you're talking about, the robot shoe scanner, becomes applicable even for companies that already have a digital version of their shoe, just because of things that could happen to the shoe eventually. Maybe, and I use the shoe being broken into as just an example, but maybe for modifications, I don't know, maybe for other things.
Here's one. Here's another thing that it can be used for, quality control. Right? So you can imagine one of these robots essentially like scanning shoes at the manufacturing lines, making sure that they're being made to spec, right? So that the problem of shoes being made to the wrong size, to the 11.25 that I was talking about, doesn't happen, right? They're always made to spec.
Okay.
And most things that are manufactured, that happens, right? There's some kind of quality control equipment that does that, right? That makes sure that things are being made as they're supposed to or as they're expected.
Yeah.
But for footwear, there's really no good tools to do that. You know how to do quality control right now for sizing?
No.
They'll just have like one person that's a size, say 10.
Yeah.
Take out a size 10 from the line, put it on, feel it out, and then from there say, oh yeah, this is good or this is bad.
Really?
Yeah. So that's how it's done now for most companies.
I see why it doesn't lend itself to a lot of like leg sizes. Like not everyone's foot is the same depending on where you're from, you know. You could have a high top, a wide foot, and things like that. So if it's just catered to some dude who just put his leg in, then that becomes a problem.
Exactly.
I'm going to go back to the discussion on fit just a little bit because I started thinking of something just now. I recently went to have a suit fitted, right? And I started thinking about it. I was like, I have to have a suit that fits me exactly. I have to have pants that fit me exactly, like fit me well. I had tailor telling me you got to take a millimeter off here. And I was like, wow, this is nice. But how about shoes, right? Are there companies out there that make like, I can't think of anyone who has ever told me I went to have my shoes custom fitted. You know what I mean? Like clothing. Is this common or is this, and if it is, or if it's not, is this something that would take off?
It exists.
It does?
It's rare, but it exists. It used to be that that's all there was, right? You go to the cobbler and they'd make you shoes, right?
It used to be that way?
It used to be that way. It used to be a lot more common. Yeah. Same thing with clothes, actually. Like if you look back in history, there's a period where you would have all your clothes were custom made.
Mm-hmm.
You know, you'd go to a local tailor or whatever, and they would actually make the clothes for you, right? So it was like really high quality, lasts forever, and it was like made for you.
Yeah.
And then, industrialization came in, and then we started like automating a lot of that. So, things are just now made in discrete sizes, and hopefully it fits as many people as possible.
Yeah.
But nothing is really made to fit any one person in particular. So it used to be that way. We moved away from it. And I think one of the main reasons was, to make things cheaper, right?
Mm-hmm.
And now I think that we actually are getting to a point where the technology in manufacturing automation combined with, say, Eclo's technology can be used to have the best of both worlds.
Mm-hmm.
So have the cheap mass-produced garment and footwear along with the perfect fitting methods of tailors.
Mm-hmm.
And that would be Eclo, right? So combining both of those, I think are possible now. So you could order shoes that are made specifically for you, but are still cheap.
Yeah.
Right. That's the other thing that I guess I forgot to mention is the cobblers now, if you want to get shoes made specifically for you, it's going to be really expensive.
Wow.
The cheapest I've seen is probably like $500. Right. And then I've seen,
for shoes,
thousands of dollars for shoes. Yeah.
Wow. Well, they've got to be real good dress shoes, no?
Yeah, they're really good. Yeah, high quality, but I think for most people,
that's unaffordable.
It's not affordable or it's not worth it. They're like, I'll wear these dress shoes once in a while. Like I'll just, even if they're not perfectly fitting, like it's fine. You know what I mean?
Yeah.
It's not worth the extra $300 or whatever. So I think that's the general mentality towards it. Because we've considered a lot of times, getting into custom fitting footwear. But yeah, that's the question I have is, do people actually want that? Are people wanting to pay a little bit more for custom?
It's all down to pricing, right?
It's all down to pricing.
I mean, it's money. If the whole assembly line type shoes come out to, let's say, $50 each, but you can drop this down to, if you want it custom fitted all the time, you're going to pay $80, then I don't think you're going to have a lot of problems getting people to adopt it because it's going to fit me exactly, right? But if it's $50 to $500, then then you will find some people, and that's it.
Exactly.
Yeah, so market isn't big enough. Okay. I know we've talked about the scanner app, the shoe scanner, but let's explain this to the audience a little bit. What's the user experience like? So walk us through like how a user will use the app, just step by step.
Sure. So imagine you're online and you're trying to buy shoes. You find something you like, and then you're on the product page. And then from there, you get to the question of what size do you want, right? So if you know your size, then you just keep going as usual. If you don't know your size or you're not sure, there's going to be an option for you to click try on virtually or some version of that word, right? Different retailers like different ways of saying it. So you click that, and then from there, our system pops up. So we have a widget that essentially is a window that's going to start asking you questions and walking you through the process. So the Eclo widget pops up. It's going to ask you questions like what type of footwear you like to wear, what sizes you normally wear, there are other sizes you sometimes wear, how do you like your shoes to fit, snug, things like that. Do you ever have places where you feel pain in your shoes, too tight, too loose? What kind of socks you're going to be wearing? So those types of questions takes about 30 seconds. And at the end of that, you can get a size recommendation just from that. Okay. If you want to have a little bit more accuracy, you can click to scan your foot, right? And that's the most accurate approach. So if you click to scan your foot, from there, QR code appears. You scan that with your smartphone, and then that's going to walk you through downloading the app and scanning your feet. So the foot scan with the app takes maybe, let's say, a minute for the tutorial and then a minute to actually scan your feet, right? It's pretty quick. And it's a one-time thing. Once you're done, you're done. You don't have to do it again unless you're growing or, your feet change for one reason or another. So once your feet are scanned, the widget is connected to your app session, and it knows that you just scan your foot or your feet, and then from there it gives you a size recommendation.
Okay. For that specific retailer?
For that specific shoe.
Shoe. Okay. Shoe. Yeah. Sorry, not retailer. Yeah. That's specifically shoe. Okay.
Yeah.
That's what, 90 seconds? Top to bottom?
Yeah. So it's about 30 seconds if you're just doing a survey. If you're doing a survey and then scanning your feet, you probably do more like 5 minutes, downloading the app, tutorial, scanning your feet, and then, yeah.
So in 5 minutes of a customer's interaction with a particular shoe, they can become a customer that actually buys versus a customer that just drops off because they are not sure of their shoe size. They're like, I don't really know about the shoe size. This brand and this particular shoe release, I've never bought it before, and I have a lot of experience buying shoes and it not fitting me, so I don't really know what I'm doing, so I'm not going to buy this shoe. I'm just going to go buy that old Nike that I had previously that I know the size of.
Exactly.
So
yeah, that's it.
Yeah. So yeah. Okay. That's it. I mean, hey, that's a good selling point right there.
Yeah.
Conversion.
Yeah. Plus, if you've already scanned your feet, right?
Yeah.
If you scan it for when you were trying to buy some shoes for a wedding or whatever, right? That scan is done, right? So next time you go shopping, wherever Eclo is available, you have your size right there and then. So the more you use the system, this is AI. So the more you use it, the more information it has about your preferences, the better it gets.
Yeah.
Right. So the more likely the next shoes you're going to order are going to fit well, right? So.
Oh, I'm very excited, man, to see on this podcast, I've had a lot of discussions about AI, but this is one of the few instances where it actually makes a lot of sense. Where it's now relating to the human body in some way that is not intrusive, that just helps you figure out something that is going to be comfortable on your feet. That's really nice. It's really nice to think about, especially the aspect of it learning. Yeah.
Yeah, exactly.
So let's talk about your collaboration with shoe brands. You mentioned, Zappos is not a shoe brand, which is a shoe website, I guess, right? But specific shoe brands, you mentioned the process of scanning with the app, is to lead the customer to a specific size that works for that shoe for them, right? Yeah. But would you be working with brands and retailers for just size data, or are you just developing a more universal measurement system for them?
Yeah.
If you can talk about that.
Yeah, no, it's a good point. I'll expand your question even more, okay?
Okay.
So it's really not just about sizing.
Okay.
It's about fit, ultimately.
Oh, yeah. Right? I remember that.
And fit as application throughout the entire vertical of footwear development, manufacturing, retail, right? So what we've been talking about so far is addressing one part of fit-related issues in retail. Okay, and that's probably like the most obvious. It's the one that I decided to go solve when I first started the project. But there's a lot more to it. So, for example, if we have an AI that does indeed understand fit, right? We do. Well, I should rephrase that. We have an AI that understands fit. This AI can be used not only for helping you reduce returns, but it can also help you figure out how to design your products from the very beginning, right?
Yeah.
I mentioned earlier, it can also help you with quality control because it knows what things should be looking like, right? So it can tell you, hey, this isn't being made to spec, right? And then it can help you figure out what size you need. And then it can also help you figure out what shoe is going to fit you best in an entire store, right?
Wow.
So imagine you're shopping on Zappos or Amazon or Nordstrom or any of those that have multiple brands, right?
Yeah.
You'll be able to shop not only by color, not only by type of shoe like athletic or whatever, but you'll be able to shop by what fits me best. Show me the shoes that fit me best.
Yeah.
Right? Because there are some that are going to fit you better.
Yeah.
So, you could make it specific for hiking shoes. Hey, I want some hiking shoes that are going to fit me. I don't really care if it's the best looking one. I just want something that's comfortable when I'm hiking. Right? So now you'll have that option. Right? And that's something that isn't available unless we have this AI and we have this whole system.
It's funny, I've had a discussion about what really matters as a founder, as you're building a company. It takes a while to realize that at the end of the day, it's about what the end user really cares about and what their experience is like. And just thinking about it from that standpoint helps you really figure out what you are offering, right? How your system actually is supposed to work and what things you're going to include,
right?
What features you're going to include. So thinking about it from the standpoint of, I go into a I don't know what store sells shoes physically.
Foot Locker.
Foot Locker, yeah. I go into a Foot Locker and I'm just able to just like go in there and just pick out a specific shoe release that's gonna fit me and just ignore the other ones because that one fits best. And you could probably still refine it and say, okay, 10 of these options fit me, right? Maybe it's not just one, maybe it's 10 of them, and then you have a selection of 10 options that you can choose from, and then you can start thinking about color options, start thinking about other things too, and that's huge. That's huge.
That's right.
Because if you go on Amazon, for example, and you search for, I don't know, hiking shoes, and you get 1 million results, then you get what Amazon actually wants you to buy, what they show to you, and then you maybe look at a few orders on the first page, and then you're like, okay, I guess this might work, versus all of these shoes, all of these 1 million results, this 10 fit me well. Now I've narrowed it down versus just like shooting in the dark. Yeah,
exactly.
That makes sense. Okay, so I think we kind of touched on this, but it's very important to set this to basically say this out loud. Who do you envision benefiting the most from Eclo's technology? So we talked about the retailers and brands you work with, the end users, the customers who actually would fill out the survey or actually use the scanner app, but who do you envision? And it could also be a specific type of customer who needs a specific type of shoe.
Yeah, it's hard to say which one will be benefiting the most, right? I think the most important for me is that they will all be benefiting, right? The retailer, the customer, the environment. So that to me is more important, that, it's like a win-win-win all around than who's going to be benefiting the most. Because they will all, I think, be benefiting pretty significantly, in my opinion, right? That, I don't know if any one of them is
benefits more.
Yeah.
Well, the retailers and brands will make more money. And the users will be more satisfied.
That's right.
Yeah, shoe buying experience or clothing or apparel buying experience will be more pleasant. So now let's talk about a bit of your background. And we both did our PhDs together at Virginia Tech. And when you were there, you were working on something called, or generally described as, biomimetic robots or things of that nature. So specifically, you designed and made biomimetic robots inspired by Jellyfish. So what was it like working on that whole project for your research?
It was really cool. It was a super fun project. And I'm really happy I got to work on that. We were basically trying to make robots that look and behave as much as possible like the natural animal. And our robot, as you said, was inspired by Jellyfish. And going in, like, I didn't know anything about jellyfish, besides that they can sting you, and that's pretty much it. But I learned a lot about the animals. I learned a lot about robotics and everything in between.
That was fun. As someone who was working on energy at the time, I was always fascinated by the idea of powering animals that weren't animals. Did you guys ever get to a point where you thought you could make jellyfish that would actually look like jellyfish in the water, or things of that nature, for example?
That was the goal. So that's what we were aiming for, right? Is to make jellyfish that look exactly like the ones in the water. But it was really challenging. Like, I know you remember, like, there's people in our lab that were trying to make like humanoids, right? And that was tough. That had a whole other different type of problems. But the ones that we were struggling with is jellyfish are just like a blob of jelly, like, it's not what robotics is used to, right? It's it's flexible actuators, flexible structures. Everything is non-linear, like it's not these like a rigid bodies. So when I started on this, it seemed to me like the research on soft robotics was pretty early, right? And I felt like we were pretty early in that. I feel like now I've been seeing a lot more papers and a lot more labs working on soft robotics. But back then, it felt at least that there wasn't much. And so it was really tough to try to replicate the jellyfish. But it was a lot of fun. Yeah,
I can imagine. I don't know if we can get into the implications of that for like military purposes or things of that nature. Like, what was the overall point of making something like this? Was it for spying purposes or what?
Yeah. I think
you can say that.
Yeah, it was pretty. I think most of the project was pretty public.
Okay.
Most of our findings were public. So yeah, everything I'll say is all stuff I published. So the applications were both military and civilian. The military applications were, obviously like blending in the environment. Maybe spying and getting access to information you wouldn't be able to otherwise. The civilian applications were the same, but for animals, right? It was like blending in with the environment, blending in with the animals around you, being able to study them, study the currents, and have as less of an impact on the environment around you. But I think one of the things that was probably a bigger reason for proposing this project in the first place was they wanted to have systems that were more efficient and maybe more robust than what was out there at the time, right? So like underwater vehicles, autonomous vehicles, tend to be these big or small submarines. Let's put it that way. They're like small submarines that they would just like put in the ocean and then have like a long cable tying it back to the ship.
Okay.
Right. And then they would just kind of have to be where the submarine is.
Okay.
Right? But what inspired our project was the idea that, hey, animals are able to, swim forever, right?
Yeah.
Like for long distances, long periods of time. There's no ship like feeding them as they go. They're able to feed along the way and so on. So it was like, how can we make these underwater autonomous vehicles be more like the natural animals, right? So I think that's kind of what inspired the project. And the animal that was picked for our project was the jellyfish because it's very efficient. It doesn't swim very well in terms of like speed or any of that, but it's able to swim for very long distances and cover long distances without necessarily being a good swimmer. So that's, if you think about it, that's actually a really good trait to have, right? Being able to cover long distances without necessarily being a good swimmer.
Yeah.
So how do you do that? So those are some of the things we were looking at with the jellyfish. How is it able to cover such long distances without, swimming that fast?
Yeah, if you build a ship in the shape of a jellyfish, you will go nowhere. It doesn't seem to have the aerodynamic structure but not aerodynamic in this case, but more fluid. Hydrodynamic, yeah. In this case, yeah. Okay. That sounds very, very interesting. We'll get into it some more, but for now, let's just define the term biomimetic in the context of engineering.
Biomimetics is studying nature to help you in your engineering design or help you solve engineering problems. Is how I would put it.
So basically looking at what happens in nature or biological systems and
how does nature solve this problem that you're trying to solve?
Oh,
right. How, in our case, it was like, how is the jellyfish able to say deform, and how can we deform the same way with what we have, right?
Yeah.
So it's looking at how nature does it and trying to understand why it does it that way and how it's helping it, right? And how it could help us, right? So there's a lot of answers to these questions. Like some of them are answers that are related to performance, but the another thing to consider is nature sometimes does a bunch of other things that you don't necessarily want to do as an engineer. Meaning like the jellyfish, right? The jellyfish, the animal needs to feed itself.
Yeah.
Where for us, it needs to feed itself. It needs to mate. It needs to, do these other things that we don't necessarily want our robots to do, right? So whenever we're trying to study nature for certain answers, we got to account for those things that it does that we might not want to do.
Yeah.
If that makes sense.
Okay. That brings me to a question. I had a guest on this podcast, Roger Pessina, who is building quadropter drones, some type of drones for surveillance purposes, right? But the interesting thing about those drones is they nest somewhere. Is that they have charging stations. Basically, they can surveil for a while, go charge themselves, and go back. Something of that nature, I think, right? When you started talking about asking yourself the question, how does nature solve this problem? If you want a jellyfish to exist, a robotic jellyfish to stay in an environment for a long time, you could just have like fake fish, whatever it feeds on naturally, you can have those like in strategic locations, and then it can go like charge itself. Yeah. In this case, instead of underwater, instead of instead of just dying out.
Yeah.
Right? Pretend that it's feeding and then come back.
Sure, yeah. Yeah, you could do that.
Yeah.
That's like biomimetics for like the charging station, right?
Yeah.
Biomimetics for another part of the ecosystem.
Yeah. Yeah. I just thought about that now. That would be so interesting if someone was working on it. But this is all background stuff we did in grad school, or you did in grad school. So, but, with limited resources and being in Blacksburg, Virginia, when you were designing the robots, did you have any opportunities to interact with actual marine biologists or any live jellyfish?
I did.
No way.
I did.
Yeah, I didn't even know.
Yes to both. Yeah.
Yeah.
Yeah, and that was probably one of the coolest part of the project. We were working with a group of biologists out in New England, and they were the specialists. They're the guys that I would literally call to ask questions about jellyfish. Be like, why did they do this? How does he do that? Can you explain this? Can you explain that? And man, that had to be one of the best parts. One story about that, actually. So every once in a while, we would go up to New England and we would do some testing with them. And one of the first times we went was right after I finished my first jellyfish robot. But it was a group project. So after we finished our first jellyfish robot, and it was called Robo Jelly. And we brought Robo Jelly up there, and I didn't finish it. Right? It wasn't finished. By the time we were driving, it wasn't quite finished. There was this one last part that I had to put on, but I actually kind of did it on purpose. I just never tested the final product.
Yeah.
And essentially what it was is, imagine jellyfish is like this half sphere, right? And there's like a bottom part to the sphere that, from my observation, it seemed like it was passive, meaning like there was no actuators in there, right? So when I build the robot, I put all the actuators at the top part, and I built that, but I didn't hook up the passive part, which is like this bottom flap is what we called it.
Okay.
So we drove up there with the robot half finished, if you will, and we put it in the tank the first day, and the biologists were studying it, right? They were looking at it and they were trying to figure out like, is it gonna work? Is it gonna swim? And when we first put it in, it wasn't really swimming. It wasn't going anywhere. It was pulsating, but it wasn't going anywhere. So I said, well, I have one more trick in my bag, right?
Uh-huh.
And they're like, oh yeah, what is it? So I explained to them, it's I think the passive flap, and it goes at the bottom. And I'll put it on tonight, and then tomorrow we can test it. So they're like, that's probably not going to do much, but yeah, sure, whatever. So the next day, they come in, and you remember, like, it was all like silicone, and I'd have to pour it and these molds and all that. So I poured everything, and the next day it was ready. So we put the new version in the tank, turn it on, and sure enough, it just starts swimming. It just starts pulsating. And essentially, that was kind of a breakthrough moment for us, because to me, it was obvious, right? But to the biologists, they were like, wait, why would a part that's passive help that much in the propulsion?
Yeah.
Right? And then, so they started like wondering, what are the implications of that? Like, what we started publishing based on that finding, which was essentially an iteration between the biologist and the roboticist, right? It was the biologist telling us how the natural animal works, and then it was us building something, and then kind of coming back and saying like, hey, how about this? And then them learning from that robot, right?
Yeah.
So yeah, that was definitely one of the highlights.
So they were learning from you guys then at the same time.
Yeah, exactly. Yeah.
Yeah.
And what was nice about the robots is you could tweak any parameter, right? Where the real jellyfish, you can't just say, hey, I want you to be longer this way and this that way to analyze what happens to the hydrodynamics. Where the robots, you could, right?
Yeah.
So we got it to a point where they were so close that we could kind of tweak these parameters, and the biologists were also learning from the robots on that side.
Wow. Well, You had fun going to New England, right? Was that was that in another university or just some lab?
So the biologists were in, if I remember correctly, in Providence. And then they had their labs in Woods Hole, Massachusetts. And I forget, there's the Woods Hole like university or really famous lab. And then there's another lab that is like right next door, and I forget what it was called, but that's where we were.
Okay.
It's all kind of part of.
It's been a while now. So
it's been a while, yeah.
Yeah, but fun times. It's always fascinating back then, in grad school when you go to travel. You go for conferences, you go to collaborate with other labs, you think you're having fun, you're having a blast.
Yeah, yeah, definitely.
Yeah. Okay. All right. Let's dive into the tech a little bit. For the jellyfish, I know it was made of, it was very, very soft. And it was hard sometimes to actually see what was inside of it. But you had a bunch of things in there. What were those things? Like the components of it?
So the jellyfish was silicone. And then that was like the body, if you will, right? And then there was... we use smart materials. Shape memory alloys is what we use for the actuators. So the shape memory alloys we had look like a hair, long hair, and it's like a wire, right? So those wires, when heated, they would contract just a little bit, right? So that was our artificial muscles. So you had those, and then you had essentially a piece of very flexible metal that we would put in there. That combined with the shape memory alloy would create a curvature when it actuates. So whenever the smart material would actuate, it would curve the bell, the jellyfish, into creating this swimming motion.
Okay.
So those are really the main components of that first robo jelly that we built.
Did you have any cameras in there?
No cameras. No, not on that one.
Yeah. Only externally from a distance, but not within it?
Not within it, yeah.
Oh, man.
We were more focused on like replicating the propulsion in the beginning.
Yeah.
So that was where all our kind of energy went, is like looking at the hydrodynamics and making it swim properly, and looking at how we can reduce the energy consumption, things like that.
Yeah.
And yeah.
Oh, nice. I remember back then, you guys, your work was always like getting covered, by Virginia Tech itself, and you guys had coverage from CNN and PBS. What was it like to be so, recognized for what you're doing?
It was cool, man. Yeah, I'm not gonna lie, like I was very motivating, right? To have your research be like, to see that people were interested in it, right? And sometimes I almost felt bad because like a lot of the other projects weren't getting like CNN interviews.
Man, I wasn't in CNN in grad school.
Yeah. But yeah, so I mean, I realized then, and even more so now, that we were lucky in that sense, right? It's not, I don't think it's that we were better engineers or that the technology was better or anything. It's just like the subject was interesting to people at that time, right? So I think that's why it got covered a lot. But yeah, as engineers, as grad students, it was definitely validating and motivating to have that attention. I got to say though, like most of the times that those opportunities would come, it was always after like all-nighters trying to get the robots to work or finish them or whatever for whatever shooting we were having. So like I watched some of the interviews and I'm like, man, I slept in like 40 hours or something, like at that point. So yeah, the actual, shootings were usually like pretty stressful and had a lot of work put into it.
Yeah, I mean, grad school was weird. It was actually more fun to pull all-nighters in the lab than to do it during the day. All-nighters, and during the day. So many robots have been created to mimic animals like crabs, meerkats, and dolphins. BBC Earth posted an article talking about an army of crabs were built to protect a spy robot from stingray, which went viral actually on social media and got about 20 million views. So where do you see animal mimicry heading, especially with the advancements in AI?
Honestly, I think we've always been mimicking nature, right? I would argue that airplanes is biomimicry, right? We were probably looking at birds trying to fly ourselves, and eventually that led to airplanes, right? So I don't think that'll ever stop, right? I think we're constantly looking at nature to figure out what it's doing. AI, right? Like neural networks, right? Machine learning, maybe I'm sure like the brain was an inspiration to a lot of what we have now. Any field you look at, I feel like at some point we've looked at nature one way or another, right? To see how it happens, how it's used, So yeah, I don't think it'll ever stop, until we've figured everything out about nature, which I don't think is going to happen anytime soon. We're constantly going to be inspired by nature.
So I'm thinking about this weirdly right now. I'm thinking, are we likely to replace a lot of things in nature eventually, or at least the utility of a lot of things in nature? For example, let's say we built horses, robotic horses. Now, no more. The Kentucky Derby is full of robotic horses. Is that like likely to happen across all of nature? You know what I mean?
Yeah. I see what you're saying. Hopefully not.
Okay.
Hopefully we keep like real horses in the Kentucky Derby. But I mean, we're replacing humans.
Yeah. So why not animals then? why not nature then?
Why? I mean, we did like tractors, right? Tractors have replaced horses and buffaloes, and like whatever we were using nature for or animals for, we've replaced it in many ways, right?
Yeah.
Now like we're using cows, but for food, not for the practicality of what they can do physically or whatever, right?
Yeah.
So yeah, I mean we've been doing that for a long time.
So we're gonna keep doing it, and AI is just gonna make it worse, better, whatever you want to say, right?
Yeah.
So let's talk about your time at NASA. You had an incredible opportunity to intern at NASA a while back. What were your, important highlights from that experience?
Wow, yeah, NASA was great. So let's start from the beginning. I was at Arizona State and doing my undergrad in aerospace engineering, and eventually I joined a program, a student project called Ascend. And there we were building these little satellites, if you will, that would gather information of the atmosphere as it was being launched with these weather balloons, right? So we'd make these little payloads that had all these instruments that would store data on it, and then would measure like temperature, pressure, and things like that. That eventually morphed into unmanned vehicles, right? Autonomous vehicles. And we, like as aerospace engineers, basically made that payload have wings and controls and be able to fly and stuff. So anyways, that project was sponsored by NASA, was funded by NASA. And every year they would have one spot for one person to go to a NASA center and do an internship. So my junior year, summer of my junior year, I was lucky enough to be that person. So yeah, that's how I ended up at NASA.
That's incredible. Aerospace engineer, mechanical engineer, and software engineer, everything. Jack of all trades, master of all. Yeah. In this case, I guess. All right. Would you say like your work during your internship contributed to anything, any of NASA's missions, like specifically?
I don't know. Yeah. Maybe. I like to think it did.
Mm-hmm.
Yeah, basically, when I was there, I was working with a scientist that was working on these pulse plasma thrusters, is what they call them. And they were essentially the propulsion method for satellites, right? Satellites that you want to send in like deep space or something, right? It needs to propel itself. So that's what I was working on, is like helping in the propulsion system for that. So my work was basically help make this model that was used to simulate how the propulsion mechanism would perform in space.
Wait. Talking about satellites that thrust into deep space.
Yeah.
Do they ever get returned, or did they become space debris, or what?
I think for the most part they don't return, right?
Wow.
Because it's so far and it takes so long just to get where they're going. So they just like transmit the information back.
Yeah. It's I was very intrigued by that, and for my own personal reasons, intrigued by how to power things like that for an extended period of time, right? So that they can at least return after a while. But I don't think anyone cares. Just send it to space. Don't care about how it returns, and we get whatever we can get and call it a day. So last question on NASA and space. So do you have any hopes for where space exploration goes in the future, especially with a lot of I don't want to say I want to call them I want to use a certain qualifier for them, but I'll make it simple. Really rich billionaires started new space organizations like Blue Origin, SpaceX, and all that. Are we likely to be living on Mars soon?
To be living on Mars, are we likely? I would say define soon. That would be my first question.
100 years or less.
100 years or less? Yeah.
Yeah.
But like when you say living, like you mean like a village of people just hanging out, going to school and going to the bar and stuff? Like, is that what you mean? Or you mean like there's like scientists there that are, doing research and stuff?
I think scientists doing research.
Okay. Then yeah, I think that's definitely possible within 100 years for sure, man. Tech has been moving so fast, right? Just look in the last 5-10 years. It's insane, right? Elon Musk, SpaceX, what they've done there is unbelievable. Right?
That's true.
I was looking at how often they've been launching over the last 20 years and how fast that's like accelerated, meaning they were launching once a year and then it was twice a year. Now it's like dozens of times a year, right? And it's like some insane amount.
It looks like every month nowadays.
And multiple times a month sometimes. And that in itself is a revolution in space, in space technology, in my opinion. Being able to go to space that often, for I don't know what the price are, but I'm sure it's a lot more affordable than it was 20 years ago. That's a revolution right there. The biggest barrier to space has been getting there, right? The cost of taking something from Earth to space is what's been prohibitive for years. So SpaceX is, to me, like revolutionized space industry in that way.
Yeah, I actually know a few companies that actually 3D print materials for space companies.
Cool.
Right. So now you have an entire rocket that's 3D printed going into space. I mean, it didn't go all the way into the orbit. I think it crashed. What was that 3D printed rocket that crashed recently? And they sent it to space, and I think just right outside of the Earth, just before entering official space or whatever, it crashed. It just like went back down. Yeah. But at least it went really far, and it was completely 3D printed.
Nice. Well, the next one will probably work.
Yeah. So yeah, hopefully.
When I was in my internship at NASA, this was in, 2008. Before 2008, so 2004, 2008. I remember going to like a little symposium of like researchers there showing their work. And one of the projects was a 3D printer printing metal for the moon. Right? And the selling point was we're going to bring this 3D printer to the moon, and it's going to be able to print any tools that we need, because going to the moon, going to space is very expensive. So just bring one equipment there, and then it could make everything else that you need.
Wow.
Right? And this is before 2008. Like, this 3D printing was not a thing, back then. And these guys were already, 3D printing metal for the moon.
Yeah. It's incredible. There's a company called Vada. It's right here in California. I don't know if you know them. Who they want to your point, the idea is they want to build factories in space. So this idea of actually printing things, 3D printing things in space, making medicine in space, like drugs and things like that, it's huge now.
So you're
zero gravity and all of that positives that space has above Earth is really their selling point.
Yeah. So you were asking me about living on Mars.
Yeah.
Right? And as cool as I think that is, and as big of a milestone it is, that's really not what I'm most excited about space right now. What you just described, like the ability to manufacture things in space that wouldn't be able to be manufactured in gravity, right? Like that's incredible. That's much more useful, I think, in our day-to-day lives. But another thing that gets me even more excited is asteroid mining. I don't know if you've looked into that.
Asteroid mining, no.
Asteroid mining, yeah. So there's these asteroids in our vicinity, right?
Yeah.
That are worth, trillions upon trillions upon trillions in minerals, in like, I don't know, platinum, gold, whatever, right?
Yeah.
It's these minerals, elements that are just out there, floating in space. And like, if you were to bring, if you were able to mine one of those and extract what you need and bring it back to Earth, or even use it in space for manufacturing, that'd be incredible. Right?
Yeah.
And not only would it be of huge value in itself, but it would also mean that we don't have to mine Earth, right? Which is very destructive, very polluting.
I see your point.
So to me, like, if we can do asteroid mining or get materials that we need from space, like literally like rock debris, like floating around, that'd be amazing.
I never thought about that. Wait, it reminds me of a movie. It's not exactly the same thing, but they had these drillers.
Oh yeah. Armageddon?
Probably, that's what it is. They had these drillers.
They drill a bomb into the asteroid so blow it up. Yeah.
So that it doesn't like hit Earth, like it explodes.
Yeah, exactly. Yeah.
That's what I was thinking of when you were talking. It's that's the name of the movie, Armageddon? It had this
Bruce Willis.
Okay, yeah. It is a movie then. Yeah, it is. Okay. Yeah, okay.
Yeah, I like that, but instead of drilling a bomb, you drill for gold,
whatever.
or,
for whatever you're looking for. Yeah. Okay. The only thing I'm worried about is if you disturb an asteroid, if you can get to an asteroid and you disturb the natural structure of it, then you might change its behavior, and it might impact.
They're constantly colliding with each other.
Oh, they are?
Yeah. I mean, it's,
you're not going to make it worse then.
I think it's pretty chaotic up there. You know what I mean? I don't think
you got to build that in an automated way, though. You don't want to be there when they're colliding with each other.
Yeah, no. You want to send robots for sure.
Oh, yeah. Okay. Yeah. There's a lot to talk about there. Yeah. Wow. Okay. All right. Let's talk about some of your work within the entrepreneurial space, if you will. So you're a member of Go Paladin, an organization empowering underrepresented entrepreneurs. So what does being part of this organization mean to you?
To me, it means giving people an opportunity that they might not have otherwise, right? Giving people help that others might be getting, but they're not because of just the way they were born, where they were born. I think that's what it means to me. And I definitely haven't been part of that community as much as I would like to, but it is a subject that's really important to me, and in any way I can give back, I'm down.
That's very good. What would be your advice for aspiring founders? You and I have been in this game for a long time now, since grad school. All we've been doing is entrepreneurship. Well, for the most part. Based on your experience, what would be, someone came up to you and said, I want to be a founder, I want to start a startup. What would be the first thing you tell them?
Oh man. The first thing I'd tell them is like, it's really hard. Are you sure? I would question them to make sure that they understand what it means.
Mm-hmm.
Because I think a lot of people think of entrepreneurship as this romantic idea of being your own boss, having your own schedule, being able to take vacations when you want, things like that, right? And honestly, like the opposite, it's the exact opposite of that, right? Everybody's your boss all of a sudden, like the customers are your boss, you can never take time off. You're always working. It's way stressful. So yeah, from my experience, what people think entrepreneurship is and what it actually is very different. So the first thing I would do is like check with the person to make sure they realize that, because I don't think a lot of people want that. And I know a lot of people are not cut for that. Right? So, and there's nothing wrong with that. It's just like you should know before you jump in. You know what I mean? So I think that's the first thing I would establish is like, you sure this is what you want to do? Are you sure you know what it is? And honestly, like, I don't know if that's advice, but I feel like that's a good thing to know.
I mean, it's good to know. Yeah. And it's good to know just at least to make sure the underlying assumptions are correct.
That's right.
It's not a fun ride. It's something you have to actually want to do and enjoy doing.
Yeah.
And know that it doesn't make you a boss of people or something. It's, yeah. Okay. A lot of founders of, a lot of CEOs of very successful tech companies are engineers. Do you think having a degree in engineering is needed to be successful as a founder?
Needed? No. No. But I think it's probably important for most scenarios. Yeah, I've seen both, but I've seen people successful either way. I've seen non-tech founders being successful at a tech startup, and vice versa. So I think both can go. Both have their pros and cons. I think that's the thing about entrepreneurship. There really isn't like a formula that works for everyone, right?
Okay.
Like that's just, I don't think that's the case.
Okay.
So yeah, I think either is possible. But like, if you're not a tech founder, you probably want to surround yourself with tech people that kind of complement you in the ways that you might be missing information in.
Yeah, I agree. Regardless of what you are, you can get in. Just make sure you have the right people around you that can fill in some of those deficiencies that you might have.
Yeah.
Well, I wouldn't call them deficiencies. Whatever skill sets you don't have.
Yeah.
Hire people or have co-founders that have it.
Right, and then the other component you could add is money. Right?
Yeah.
If you have money, if you have access to money, then you can compensate for a lot of other things.
Yeah.
So it's like you need a great idea, you need skills, you need money.
Yeah.
Right. And like if you don't have one of those, you can compensate with one or the other. Right?
Yeah.
So skills here, I'm talking like technical skills, but I'm also talking about like interpersonal skills perhaps, or your network, or like stuff like that. So yeah, there's ways to win.
Yeah.
With different combination of ingredients.
True. It can even be a sales skill. I mean, if all you know how to do is sell, you can
that
go far.
That might be all you need. Yeah.
Yeah. You can go very far.
Yeah.
Okay. So in this whole startup space, in this whole space of trying to found a company or build a company, do you need a difference in mindset? Do you need to, be an innovator trying to solve problems, or someone who is just focused on raising or making money? What mindset helps best, you think?
What mindset helps best?
Yeah, helps you, succeed. Is it just being an innovator who wants to solve problems, or, when you get an idea, right? Sometimes people will say, "Oh, I want to change the world," or "I want to solve this problem for someone who I want to solve this problem for people I care about or for myself, and so I'm going to start a company around it." Whereas some people are just doing it just to make money. They're like, "I want to be rich. That's it." Yeah. What mindset do you think?
I mean, if anyone's doing anything just for money, I think is probably not a good way to go about it. Just in general, sometimes you get lucky, and maybe you don't need much motivation. Maybe things work out like right away, right? Like you develop something for a couple months, and boom, it takes off. Then it doesn't really matter what your motivation was. Like, you're successful. You know what I mean?
Yeah.
But in my case, 10 years, right? 10 years, like, if it was just money, I would have quit a long time ago. You know what I mean? So depends on the situation, right?
Yeah.
It depends on what you're doing. In some cases, I think you need to be very passionate about what you're doing, right? And it's not just for entrepreneurship. This is for like a professor in a lab somewhere, like he's probably really passionate about whatever he's researching, right? To be able to look at something so deeply for decades.
Yeah.
Right. So yeah, I think it's very dependent on the situation.
Yeah. When people see entrepreneurs, like, especially the ones that are very flashy, online, they see them, the first thing they think about is, oh, the person has money. And then their motivation the motivation they get is, oh, I want to make money like this person. And they think that's all there is to it. And, that's a very terrible mindset.
True.
True. You understand?
Yeah, that's like the Hollywood, right? That's the Hollywood
version,
right? It's because that's all you see, right? You see the companies that are successful overnight, that have big success, but you don't see all the grind that's gone behind it, right? Because that's not really exciting, right? But it's there. It's definitely there, and I think that varies for different founders and different projects.
Okay, fantastic. All right. So reflecting on your career so far, and I'm gonna go as far as from undergrad to grad school, PhD, starting Eclo, being an entrepreneur. What would you say has been the most rewarding moment?
Rewarding.
Yeah.
Wow. Most rewarding moment. The first thing that comes to mind, I don't know if that's the real right answer. I'll probably think of the best answer like tonight when I'm trying to fall asleep. But the one that comes to mind now is when I got the grant, first grant, maybe even second grant for this project for Eclo, from the National Science Foundation.
Yeah.
Was kind of like a culmination of things happening, right? It was my PhD helping me get funding for the next project, right? It was my idea of virtual fitting and my knowledge of the world and people and things like that that helped me like have this idea, let's say, right? Or, think of this solution. It was I feel like a lot of things kind of coming together and then the validation of getting the grant, right? And then the excitement of like new possibilities, like, oh man, we're going to be able to create this technology, like this project and all of that, right? I think that was a pretty big highlight for me when that happened. Yeah.
That would be the most rewarding moment right off the top of your head right now.
Yeah.
That's what you can think of.
Yeah.
That's pretty it's got to be a good feeling because it's very competitive and not everyone can get it, right? And it's something that actually gets you going to financially at least.
Yeah. It was a lot of money, right? It was a ton of money. Like,
can you say how much it was like overall?
Yeah.
You got for NSF?
Yeah. So the first grant there were SBIR grants. The first grant was it $150K?
That was back then, right?
That was back then. And the second grant was the like phase 2 of it, and that was what is it? It was like $1 million something came out in the end. So I got like a 1.2 million total.
Yeah.
Yeah.
That's incredible.
And this is coming from a guy that the most money I've ever had in my bank account was like $5,000. Like,
at the time.
At the time, yeah.
Yeah. Yeah, that's got to be very, very, very validating and very, very. It's like a booster behind you, like just
exactly
get
yeah.
you going.
Yeah, just strap the booster to my back and
yeah,
let's go.
Let's go. Yeah, that's good. That's good. So, okay. So, before we close out the podcast, where can people find you? If they want to learn more about your work, partner with Eclo, and talk about anything else.
You can find me on LinkedIn. They can find me. They can send me an email. My email is alex@eclo.com. Eclo is spelled ECLO. Yeah, those are probably the main places.
Yeah, exactly. So this has been a really fun discussion, as it is always discussing with you, Alex. I know it's been so many years since we've been friends, and we've talked about a lot of things. We've worked together in grad school. Even when I started my first startup, when I was trying to launch, I came out here to California because of you, because Alex is in California, he's doing well. Let me go there too. That was the whole idea. So yeah, and it's nice having you on the podcast.
Great. Well, it's nice being here, and it's nice to see you. At all your success, and I wish you the best.
Yeah, thank you very much. And with that, we've come to the end of another episode of the Hard Tech Podcast. I'll see you guys on the next one. Thank you for watching. If you enjoyed this episode, please consider supporting our mission of providing good quality content and conversations from within the hardware tech space. And all you have to do is like the video, share it with your friends, and subscribe to the channel. Thank you for watching.